All right, so today's video, it did not go how I thought it would when I started out doing this a couple of days ago. We got like 95, 97% of the way through the job, just cleaning up and getting ready to put things back together, when I noticed something that was fairly small but very significant in the overall operation of this job that we're going to be doing. So it did put a wrench in the works. It halted all progress, but I'm actually not too bummed out about it because now I get to, well, number one, order more parts. That's always kind of fun. But two, and more importantly, I get to do something that I've never done before. I get to learn a new aspect of working on cars. So sit back and enjoy the content. If you're going to be building a high-powered GM car or truck and you need an automatic transmission that's not going to break the bank, well, you really only have one great option. Go to the junkyard and grab a 4L80. They're fairly affordable, they're definitely available, and they'll hold up to just about anything you can throw at it, even with insane power levels. But there are still things you can do to improve their holding power and improve the acceleration. That's exactly what we're going to be doing today to the 4L80 that's in the Ugly truck. Now, it's been put together for about 6 months in its current configuration with a turbocharged 8.1. And on 7 pounds of boost, it makes 620 pounds of torque. But we've recently turned it up to 13 pounds of boost, and I have no idea how much torque this big block is putting out. But I can guarantee you it's well over 700 pound-feet at the rear wheels. And this truck, it probably weighs nearly 5,000 pounds. So that transmission is doing really well. It hasn't complained a single bit. Oftentimes the temperatures are kind of on the warm side. It's nearly 200 degrees when I'm running around. But we're going to fix all of those things today. We're going to improve the holding power, we're going to improve the acceleration, and we're going to help it run a little bit cooler, although I think that part will actually be in a future video. The main parts that I am going to be focusing on today are on this table right here. We have a shift kit that'll change some of the hydraulics around and help the clutches clamp a little bit harder, hold more power. And then finally, and most importantly, the main reason why we're doing what we're doing today is we get a higher stall speed torque converter that'll really help this big turbo spool up quicker and help the truck get off the line a little faster. So we've got a couple things to do. We need to get the truck up in the air and get the 4L80E out from underneath the Ugly truck. So really the first thing I got to do is get the front tire off because I need to access a lot of the exhaust components that are hidden behind the inner fender well. So once the tire is gone, I'll pop off a couple of little plastic retainers that hold the inner fender liner in place and remove it from the truck. The first thing I need to do is remove the downpipe. So there's a couple of V-bands up top, one on the wastegate, one on the turbo itself, and one underneath. And then the downpipe just wiggles out. Next up, I'll have to remove the crossover, and there's one V-band on the manifold, and the other is a 3-bolt flange on the driver's side manifold. Next, we'll just drain the fluid out of the transmission so it makes just a little bit less mess later on. And then the next thing I'll do is remove the dust cover so I can access the torque converter bolt so I can separate the torque converter from the flywheel. So out back we're going to be working on the drive shaft. So there's 4 bolts on the rear yoke at the differential. Those are, I think, a 10 or 11 millimeter. There's a couple bolts that hold the carrier bearing onto the cross member. And then finally, with those 2 things loose, you can lower the drive shaft and slide it back to slip it out of the transmission. All right, so the next thing I got to do is work on removing the flex plate bolts, and these are held in with an Allen head, and they're in there kind of tight. Ow. But basically just going to loosen them one at a time, turn the motor over so you can access all 6 of them on the 4L80, and then as soon as you can freely spin the converter, you're good to go. There's a few connections on the driver's side of the transmission, just a few plugs and wiring harness connections. You got to remove the shifter from the transmission itself, remove the shifter cable from the bracket, and then just going to jack up the transmission so I can loosen the cross member.
With that out of the way, I'm just left with the 7 or 8 bolts that hold the transmission physically to the engine. Now, some of these are a pain in the butt to get to, but if you have a really long extension and a little flexible headed 15mm socket, you can pretty much get most of them. And from there, you just gotta safely lower the transmission out of the way. You can use a floor jack, but I do prefer a dedicated transmission jack because it's got a little bit bigger pad on it, and it generally has a little bit higher height, so you can keep your vehicle jacked up in the air. I did have to raise the truck just a little bit further to get the trans out from underneath the truck with it still sitting on the trans jack, but we got her out.
So every time I do work like this laying down on the ground, I swear to myself I'm gonna get a shop or I'm gonna get a lift, but we're working on it. Those things take time and who knows what'll happen. But we at least got the transmission out, even though it was a little bit of a pain in the butt. Not too bad though. This was a good opportunity to kind of inspect the turbo kit, all the fabrication work that we did a while ago, just because it's been on there for about 6-7 months. Seen a lot of hard use, seen a lot of heat put through it, and so far everything has held up pretty well, except for the spot where the driver's side manifold bolts onto the cylinder head, because that's actually the exact same gasket that came out of the junkyard, and I've never had the manifold off, but that does leak pretty badly there, and you can probably hear it in some of my videos. It's that high-pitched chirping sound. But anyhow, the rest of the kit that we fabricated, everything is held up a-okay. And the one spot that I was like really worried about is right down here. It's the junction between the cast steel manifold and the carbon steel weld L's that I made the rest of the system out of. I didn't make this out of stainless because I figured it would be too dissimilar from the cast manifold. But anyway, the junction right there, you can kind of see where I welded the elbow onto the manifold. Luckily, there are no cracks at all, and I did kind of, when I built it, I added that little extra pad right there. It kind of bridges the two, and I figured it would be like a thermal bridge because this manifold is really thin and it'll cool off quicker. The weld L's are really thick and they'll hold heat longer. So I figured if I kind of bridge the gap on 2 spots, it'll do 2 different things. Number 1, it will make that joint stronger. Number 2, it'll kind of, like I said, a thermal bridge. I don't know if that's a thing. I'm not an engineer, but so far it's held up really good. Hasn't cracked, hasn't leaked, so we're good to go. Now, the other thing I did notice, which is kind of cool to see how different materials wear over time, is I use actually 3 different grades of stainless in this exhaust system. The first and the best is some 304 4-inch that I used in the downpipe. This is made by Vibrant Performance. And as you can see, everything has a really nice gold color to it except for the bung, because that, for some reason, I used a mild steel bung. Don't remember why, but anyway, this is really good 304 stainless. It basically is gonna look like this for the most part forever. The crossover pipe, this is made from 409 stainless, and this is kind of what most production exhausts like in a brand new car are made from. So it kind of does discolor, it kind of does corrode a little bit, but you know, right around the welds, everything looks pretty decent. So no, again, no cracks or anything like that. And this, if you don't want to spend mega bucks on a whole exhaust system for 304, good quality 409 from an American manufacturer is kind of what you need. Now, I do have one more section of 409, and this is some of that cheap stuff you buy off of Amazon. I mean, it works great, it doesn't leak, but check out the difference right here, because this elbow, this is actually 304, and from this joint on, this is all cheap 409. And look how badly, especially where we get this really hot spot in this bend, I mean, look how badly it corrodes. Like the welds, because I used a quality filler wire, the welds themselves haven't corroded, but the rest of the material, it just kind of looks awful. So anyway, when you're purchasing exhaust materials, there's nothing wrong with going with like an inexpensive Amazon material, but just remember, you get what you pay for, and you got to know what to expect, because if it starts rusting down the road, or you know, corroding, or whatever you want to call it, you just got to be prepared for that and know what you're getting yourself into. Anyway, the converter is out, or the transmission's out, the converter's still in, but this is what we're going with to replace the stock converter. This is a Circle D 265 millimeter single disc lockup. I decided against going with a triple disc because I don't actually lock the converter clutch under wide open throttle, so no need for an exotic clutch there. They actually have, I think they have a 5-disc option as well, like maybe for a diesel application, I don't know. Anyway, we don't lock under wide open throttle, so the 265 millimeter converter, I think I selected the 32 to 3400 RPM stall speed. I called up the guys at Circle D and I kind of spoke with them on the phone, and this is the converter that they recommended for this particular application, the weight of the truck, the torque of the engine, and all the gear ratio and all that good stuff. So we'll get that in, and then we will get it on the road eventually and see how it works. Now, I do have a couple more parts that I need to install along with the converter. The first, I got a shift kit, and I actually bought this like forever ago. So we'll actually put this in first, and then in that box right there below the parts washer, I actually have a transmission cooler, one of those 40K True Cools, because anytime you put a looser converter in, it's going to make a lot more heat. And so I'm going to bypass all the stock cooler stuff entirely, and we'll do that probably in the next episode. So I think today we'll get the shift kit in, get the converter in, and get the transmission ready to go back in the truck. And then in the next episode, I'll work on the cooler, and then after that, we'll get it out on the road and see how this thing drives.
Make a mess.
There's a ton of small check balls that are inside the transmission. So the first thing that I want to do is just kind of tip it over so I have access to remove the valve body without all those check balls falling out. Now you can actually install this shift kit with the transmission still in the vehicle. It's totally doable, but everything's just kind of upside down. And since I'm installing the torque converter anyway, I figured this would be a lot easier to do with the transmission on the floor or on a bench. With the pan removed, there's a filter that's in the way. We'll easily pop that out. Then the wiring harness is going to have to get disconnected. Just a couple little plugs here. This is all fairly simple stuff. And then there's the bolts holding the valve body into the transmission. There's probably, I think, like 22 of these, and they're pretty much all 10s except some 8s on the little pressure manifold. Then the valve body just simply removed from the transmission, and all the check balls have stayed inside the transmission case. Over on the bench, you've got to remove this part here. I believe it's called the accumulator. No idea what it does. But once we have that out of the way, we can take the separator plate off the valve body. There's a couple gaskets on there, and luckily that all cleanly removed. And then the first thing you're going to do is drill a hole in one of the little passages on the valve body. Then I'll tap the roll pin out, and I believe this one is an accumulator as well. And basically in this little spot right here, they need you to replace a couple of springs, and there's a certain shaped plug, the guy that I am going to be getting out right now. By the way, I did have to use a little screw in the end of that plug so I could just grip it enough to pull it out of the bore. And as you can see, with a screw in there, it actually comes out pretty easily. So there's the two new springs. There's a blue inner and a blue outer. Now, I put both in at first for kind of the average shift quality that they have you do, but I actually pulled one out later on because I wanted a little bit firmer shift. So I just left the one small inner blue spring. So I have no idea what this next modification actually does, but you have to move the manual shift valve out of the way so you can tap out the plug and the filter. They have you remove the O-ring from the end of the filter. And the actual sealing surface gets replaced with this little aluminum guy right there that has its own O-ring on it. It's a much stronger seal. It won't deform like the plastic filter did. The one thing you do have to change though is you have to slightly grind that filter so the new aluminum plug will actually fit back in the bore. All right, next up, I kind of wish I didn't do this step, but this is a pressure relief valve. So I lined up the little plate that they provide with 2 bolts and a nut, and then you just center punch the hole so it drilled straight down in, and then you drill through the valve body. And apparently the function of this is to relieve pressure if there's ever a spike that would potentially cause problems with other parts of the transmission. Now that part I just showed you there, that was the actual pressure valve itself. The little tapered end is what makes the seal, and the little E-clip held it into place. Now you've got to mark the location of 3 holes in the new separator plate, and we're going to drill these out to a specific size depending on how firm or soft you want the shift to be. I'm drilling them out to basically the largest size that they recommend. So now the new gasket goes onto the valve body, of course, after I've cleaned everything really, really thoroughly with brake clean, so there's no dirt or gunk in there. line up the separator plate, you'll put the accumulator on, and there is one last change of springs we're going to be making. The spring on the right, the green one, that will get replaced with the white spring that was provided in the kit. The other accumulator spring goes on, the body goes on, and we'll tighten the bolts, and the valve body is pretty much done. Okay, back at the transmission, we've got to pull this guy out of the pump. I'm not sure what it does, some kind of regulator maybe. I actually used a magnet onto the end of a bolt to kind of pop it out of there. That worked really good. It was one of those funky rare earth magnets. There's two springs inside here, and oddly enough, I think they're like the same exact color as the new springs in the Transgo kit. So I don't know if somebody's been in this pump before, but we'll just throw the new springs in. There's a large one on the outside and a small one on the middle. And then finally you got to reinstall a washer, and there is I think they provide a new plug for this one and a snap ring. Now, like I said, you can do this with the transmission still in the truck, but this step right here would be pretty difficult to do laying on your back. Over on the other side, this is a band apply piston. I don't know which band it's for, but basically you just pop the cover off. There's a little gasket in there. Pop the servo, that's what they call it, the servo off, and then there's an orange spring that actually gets replaced with another orange spring. So once again, not sure if somebody has been in here before or not, but same exact spring. So the servo pops back in the housing, and then the original gasket and the cover just bolt right back into place. Finally, the front center support bolt just gets removed and replaced with a new one that was provided in the kit. I'm pretty sure the only difference here is it is just made from steel instead of aluminum.
So let me know down in the comments if this has ever happened to you. Have you ever been like 95% of the way done with a project, just getting cleaned up and ready to put stuff back together, and you're really excited because you're in the home stretch, only to realize that something actually is majorly wrong and you should not continue progress? Well, that just happened to me, but let me get to that in a second. It's a good one. It might actually change the direction that we're going in the short term here. But anyway, the shift kit install actually, for the most part, kind of went fairly straightforward. There's a few things I wish I had read and learned before I started this, because when it comes to automatic transmissions, that's like the one area of automotive that I really have the least amount of experience, and that's the one thing I need to change. So this is actually a great learning opportunity. I mean, I can build engines, I can do rear ends, I can do EFI tuning, welding, fabrication, but when it comes to transmissions, it's just one of those things where it's like black magic. I can replace parts. I can usually take stuff apart and put it back together, but I just don't know what's going on. All those little worm tracks, I don't know what hydraulic circuit goes where. All these little springs and stuff that they have you change. I have no idea for the most part what they do. I just read the instructions. It says put a hole here, so I put a hole there. But that's one of the things I wish I did not do. This guy right here, this is part of the Transgo HD2 shift kit for the 4L80. This is actually a pressure relief valve, and it goes into the EPC circuit, I think they told me. I don't know what the EPC is. But basically, this little tapered seat right there goes on a hole that you drill in this passageway right there. And it kind of gets held down with bolts, something like that. And as you can see, it kind of has a little bit of spring pressure on it. And basically what happens if there is a spike in the EPC pressure, this is basically a bleed off valve, and it relieves pressure through that hole right there. And it resets itself because it's got the little spring on there, supposedly. But if you believe what you read on the internet, this guy right here can actually jam up and be stuck open if it ever does bleed off, which will leave you low line pressure, or so I'm told. You never believe what you read on the internet, but I did call the guys up at Transgo. I said, look, how often has this failed? And they said, according to the stuff that we've heard, this never, to our knowledge, actually failed and stuck open. But everyone on the internet says just leave that thing out. But I actually read that after I had already drilled the hole through the valve body and realized what the hole was for. So not a big deal. I'm just going to put it together, maybe, and send it like this and see how it goes. The rest of the stuff, you gotta pull this guy out here and replace some shims and a different plug and stuff. Probably sounds like I have no idea what I'm talking about because, in fact, I don't have any idea what I'm talking about. This is a different separator plate, and there are 3 holes, 1, 2, 3, somewhere in here that you have to drill to a certain size. I did go a little bit bigger than their recommendations. If you look on the chart over here, okay, right here. So originally it comes with an 086 drill, and I drilled them out at that, but then I did a little bit of reading, and Jake, he's a pretty well-known transmission builder. He had on a forum somewhere, he said, to drill hole C a little bigger, leave hole B. And so I kind of blended this with that. I have no idea if it's going to work, but I just put everything at 0.108, which is actually a little bit smaller. They say you can go up to 0.125 if you have a high stall speed converter. So anyway, that's what I went with on all the holes. No idea if that's going to work or not. And the final change that I made, which you guys didn't see, on the accumulator here, it originally said to put both small and large blue springs in, but if you want the firmest shifts, do just the small inner blue spring. And that's actually what I did. I took it back apart, got rid of the big blue spring, and only ran the small one. Mainly because everything I read online says the Transgo shift kits are a little bit on the soft side, so I just cranked all the settings up to the firmest. That might be a mistake, I don't know. The one thing I do know is if you have a fairly loose torque converter, it'll somewhat soften the effects of a harsh shift, which I do have a little bit on the loose side of a converter, so I'm hoping that will help me out in the long run. Now, let's talk about the problem that's kind of stopping me in my tracks right now. I was actually just getting ready to put the pan back, or not put the pan back on. I was cleaning the pan up in preparation for reassembly. And there's always a little bit of gunk and stuff on these magnets that's on the bottom of the pan, but I found something that's not normal gunk, and it's kind of small, and I don't know if you're going to be able to see it, but that little guy right there, that I believe is a roller from a thrust bearing. And it wasn't just one, there was a whole bunch of them in the bottom of the pan. Let me kind of show you in my drain bucket way over here on the other end of the shop. You can kind of see all this stuff right through here. These were all metal pieces that were sitting in the bottom of the pan. So as soon as I saw that, I started cleaning stuff up. I realized I can't really put this thing back together as is, or I really shouldn't. So in terms of symptoms, what did I recognize with the truck? Well, there has been one thing I haven't been able to quite figure out ever since I put this 4L80 in, and it's never affected how the trucks drove. This 4L80 has always shifted amazing. It's crisp. It's right there when you want it. It's not harsh. It doesn't slip. But there's always been this weird noise, like sometimes at idle, if it's in neutral, it just kind of makes a little bit more clatter than I thought it should. And I could never quite figure out what it was. I was like, maybe there's a cracked flex plate. Maybe the flex plate bolts to the torque converter have loosened up. But I checked that stuff, none of it was true. I just could never quite figure out what it was. And I'm pretty sure those bearings right there, there's a thrust bearing somewhere that's wiped out, and that's what's causing my noise. And I think, well, I'm not sure, but so this input shaft right here, if you kind of wiggle it back and forth, like there's quite a bit of play on that, and I'm pretty sure it's not supposed to be that much. I'm fairly positive something on the inside, those thrust bearings has let go, or maybe one or more have let go. So, like I said, I don't really know a whole lot about transmissions. I've taken them apart before. I'm really kind of nervous to do so, but I can't really in good conscience put this back together the way it is because I know something's coming apart. So I have a couple different options right now, and I kind of need to think about what direction I want to go. Ultimately, I wanted to have a transmission built by somebody like Jake's, you know, just have a 1,000 horse trans built, because that's where we're going to be going with this truck. We are going to be pushing 1,000 horsepower to the wheels with it. I've got the built motor. The parts are on the way, guys. I know I've been saying that for a while, but I actually placed the order this week. The parts are on the way, and by the way, we are actually making some bigger changes than I told you about for the engine. So yes, we are going to be definitely making a lot of horsepower, and I need a transmission to hold up. This is kind of like, I just wanted to change the torque converter out so I could see how it's going to react with the motor right now at 13 pounds of boost. But anyway, I can't put it back together like it is, guys. So this is where we're going to end this video, and I do have to say thank you guys for watching. Help me out, please. Click the subscribe button if you're new to the channel, if you enjoy this kind of content. I try to keep stuff fairly technical. I try to have some fun along the way. Also click the like button, drop a comment down below. Let me know what you guys would do with the transmission. Let me know if you've got a favorite builder, someone who's good with the 4L80 stuff. Other than that, Thank you guys for watching. I'll catch you in a few days.